Hi, my name is David Ogunshola. I'm the author of Early Coding for Kids, the computer programming textbook designed for children and young learners. People have asked me many times, how could you design a textbook for children? Can kids learn to code? And people are curious about using the books. And so this video is meant to explain to you what to expect when you get copies of this book, either for your school, for your kids, or for use in any club. First things first, why did we have to write this book? We're not just trying to add another subject to the classroom or create a new book in the market. There was a need in the market, in the educational sector. How do we help activate the creativity and innovation in the minds of young learners so that they are prepared for whatever comes their way? So programming is just a tool in helping to activate this creativity. And so we try to create a curriculum that programming can be taught, with which programming can be taught to children at an early stage. So who is the book for? It's actually designed for kids from the age of 5. You will notice that they are not in grades, they are in levels. So this is level 1, level 2, and level 3. We have level 4 and 5 actually. So it's designed at levels. It's designed simply such that even a child of 5 years old can understand it. It's simple enough for primary school students, but challenging enough to engage even secondary school students. So it can be used both in primary school and secondary school. At any point a child starts to learn to code, that child is in level 1. You finish level 1, you go to level 2. The curriculum is actually progressive. So what does the book teach, or what does this series teach? It takes a child from zero knowledge of what a computer program is to being able to create computer programs. In fact, at the beginning, we assume this child does not even know what a computer is. So the first thing we explain is, what are computers and how do you tell that this device is a computer, so that when a child sees something, they can tell, is this a computer or not? And basically, the rule of thumb is this: the ability to program a device makes it a computer. And so we just take them from there on and we go further into explaining what programs are. And every child gets to create their first computer program on a piece of paper, basically programming a robot to eat a cookie with a few steps and just word commands. And once that is done, they understand the principle of programming devices, machines, and computers. We go ahead to explain what the computer vocabulary and the attitudes that a child needs to develop to help them become a super programmer. Then we go into the beginning, or what we consider the most important thing in computer programming: algorithms. We explain algorithms. So we explain what algorithms are and how important they are in computer programming. To be able to create a program for anything, you need to be able to build the list of steps needed to perform it. And so kids get to start practicing by creating an algorithm for everyday activities, like taking their bath, like making noodles, like washing their clothes. If you can break any task into steps, you can build a program for it. Then we teach them about sequences. Even when you have the list of steps in a program, they need to follow the right order. You can't take your bath before taking off your clothes. There's a sequence for all steps. So we teach them those sequences and then go ahead to teach them about bugs. What are the mistakes you will encounter in programming? What causes bugs? How do you fix bugs when you have problems? So that when they actually start facing problems in their codes or when they are programming, they don't feel overwhelmed and feel, oh, where is this coming from? And then we give them what we call unplugged activities that help them practice these skills on a piece of paper where they follow algorithms. You are wondering, at this stage, the child hasn't even started coding yet. And that's the mistake that most teachers make. You start from day one, give a child a computer program to start building. They don't understand the foundations, what they're trying to do, and how to respond to challenges they have. We give them those basic understandings first, and even introduce them to what we call binary coding. Binary coding, now this is not the binary that adults know, not converting from base 10 to base 2. It's basically a representative form of coding where kids are able to use their mind to convert numbers into text, and they're able to activate their mind to do some encryption, some decryption, and solve puzzles using binary. It's after all of this, we're sure that they are thinking at the frequency. Then we introduce them to coding with Scratch. Scratch is a block-based programming language that we introduce, that we use to teach kids to code, and we're going to use this as our base language. And then using Scratch, we explain all the core programming principles and concepts, like events, like loops, coordinates, variables, conditionals, data types, and all of those things. They're going to understand. What we've done is we've explained those concepts in a way that any child can understand, and give them tasks that help them practice those things using Scratch, the block programming language. At the end of the day, any programming language these kids get to, they already understand the foundations. The loops are loops, whether in Python or in Scratch. Conditionals are conditionals, any language you go to. So we ensure that they understand those things and are able to apply them to Scratch and then to any other language. And very importantly, two more things that they will do in the book. We teach what we call computational thinking, which is basically the process of solving problems. In book 2, we start with computational thinking. There's a process to problem solving. And if a child understands the process of problem solving, they can apply that to solve any problem in any sector. So we teach you those processes and get them to actually solve problems. And lastly, we teach digital citizenship. Kids spend time online, they spend time on the internet, but who teaches them how to live on the internet, how to use the internet? You tell them passwords. So in digital citizenship, we teach them those basic things, the internet, about passwords. What are the rules for creating passwords? How not to use your birthday as your password? Things like cyberbullying, digital footprints, how you leave a footprint wherever you go to. Just basic rules for being online. And this goes on from book 1 to book 3. By the end of each book or through the series, they are able to create things with their hands. They're able to create things in the computer programming and language called Scratch, build games, build animations, basic things. I mean, you could go through the book and see what the basic curriculum looks like. And then level 4 teaches the principles of game design. So in level 4, we teach them what are games, how are games built, how do you build games, and level 5 teaches Python for kids. Like I said, this is not a computer studies book. It does not teach children how to use computers. It teaches them how to program computers. And the reason we're doing this is so that we can help activate their creativity, their curiosity, and their thinking for innovation. That's the only way that we can position these kids who are young today to actually succeed and thrive in the world that is changing, and to be able to anticipate the problems of the future. So that's basically what early coding for kids is. If your school is thinking of using it, this is the right resource to help activate the minds of your kids. It can be used at home school, in regular classroom, or even at clubs. That's basically the early coding for kids.